This is a super short video because I don't want you to try to memorize what we're talking about today. I want you to write them into your planners, or sorry, not your planners, your math dictionaries, and have an intuitive sense for how they work. These are things we've talked about a lot. So, or that you've studied a lot without formally talking about them. So we have postulates and theorems. What's important to remember is that postulates are not proven, they are accepted to be true. Theorems are proven. Then we have definitions. Definitions do not seek to explain, they just define things. So we try to not do postulates or theorems, but with definitions, we just try to say what something is in a definition. We use postulates and definitions to prove theorems. These are proven to be true. We prove them to be true using deductive reasoning. Often, we feel postulates are true using inductive reasoning. Not always, but often. We have 4 postulates so far: a ruler postulate, a segment addition postulate, a protractor postulate, and the angle addition postulate. I'm going to throw a bunch of postulates at you right now in this next slide. I do not want you to memorize these as postulate 5, postulate this. Even though the work you're going to do is going to ask you which ones justify it, I just want you to get an intuitive sense for how they work. I don't think you need me to read these to you, but they should make sense. Through any 2 points, there exists one line. Pretty obvious, right? A line contains at least 2 points. At least 2, right? Could have more, but we know it has at least 2. 2 lines intersect, their intersection's exactly a point. You get it, right? 2 planes intersect, their intersection is a line. These are postulates. We do not prove them to be true. These underscore the behavior of Euclidean geometry. Write them down in your math dictionary. Something else to look at is ways you can interpret a diagram. Look at the diagram over here on the right. Look at all the things that you can assume from the diagram. Angle AHB and angle BHD are vertical angles. Do you see how those 2 angles there form a line? They share a side, and the non-shared sides are opposite rays. Take a look at 2 lines that intersect at a point. Points that are collinear because they're all on plane P. Vertical angles, AHF and BHD. Notice that they are angles whose sides are opposite rays. They're formed by 2 intersecting lines. They share a point but no sides. Things that we cannot conclude. We cannot conclude that these 2 lines intersect, and we can't conclude that they don't intersect. I love that. We don't know if they're parallel. We can't say that. We don't know if they're not parallel. We can't say that. We can't assume that BHA is congruent to CJA. We don't know if those are congruent. We can't assume that line AD is perpendicular to line BF. They might be. It looks like they are, but doesn't matter what it looks like. These are things you can't assume. If those 2 lines were perpendicular, there would be a little right angle symbol there. And that right angle symbol actually doesn't even mean right angle. It means perpendicular. And we'll get into what that means as well later this year. Last thing I want to talk about is what does it mean if a line is perpendicular to a plane? A line is perpendicular to a plane if and only if the line intersects the plane at a point or in a point, and it's perpendicular to every line in that plane that intersects it at that point. Here is plane A. Line P and line Q are perpendicular to line T. So would be line S. So would be line L. Any line in the plane A that contains this point would be perpendicular to line T. Now that is a super short video. If you have any outstanding work, I would get to work on that now. If you want to start on the classwork tonight, you can, but you don't have to. Use this as a bonus time to work on test corrections. But there you go. Short video, sweet and to the point. Have a good day. See you tomorrow. Peace.